Today I would like to tackle Git hooks in Rust, mainly because I keep forgetting to run my test before I make a commit, and it's annoying me, and I know I can automate this. So we're going to automate it. Let's do it. Alright, so first and foremost, typically if I was going to try to solve this problem, at least in another language, Python, because that's where I'm from, I would use something like Precommit, which is a framework for managing and maintaining multi-language pre-commit hooks. They have a whole system, and they may have something for Rust. I don't know, I didn't really check that hard, but typically this is where I would go. However, in this scenario, I really just want to learn about Git hooks. So moving onward. Git hooks, the Git hooks documentation, right? There are some key things to highlight. The hooks are all stored in the hooks subdirectory of the Git directory. In most projects, that's .git/hooks. So this is a location where all of the hooks are going to be stored. When you initialize a new repository with git init, Git populates the hooks directory with a bunch of example scripts. Okay, that's good to know. Example scripts, they're being placed there. All of the examples are written as shell scripts with some Perl thrown in, but any properly named executable scripts will work fine. So this is the line that I truly care about. They're stating here that as long as the script is executable and it is properly named, it will work. Cool. That's what we need for Rust, because we can do that in Rust. And then also, since we're doing pre-commit, we should probably look at the pre-commit documentation. The pre-commit hook is run first. Before you even type a commit message, it is used to inspect the snapshot that's about to be committed, to see if you've forgotten something, to make sure tests run, or to examine whatever you need to inspect in the code. And we just want to make sure our tests run, at least in this example, that's what we're doing. There are other things we could do, but we're just making sure tests run here. And then the next line is the important one. Exiting non-zero from this hook aborts the commit, although you can bypass it with git commit no verify. So here, if you exit non-zero, as in the exit code of the program, if it is not zero, the pre-commit will fail and you will not go to the commit stage of the git process. If it is zero, everything will proceed smoothly. Okay, so taking that information and this information, let's start. Oh, there is one thing I did forget. So the commit hooks, some of them take input values. This is important to note because we need to be able to take in input values for our script, in the case that it does. So it's just something to note. And the way we do that in Rust is via args. So standard library environment args. And they have an example down here. We just import it and then print out everything on a separate line. So we're going to do that first. Alright, so let's open the terminal. And I already created a project. Here we go. It is empty. And do ls-a to see everything in here. We see that there is already a .git, which is what we're expecting. And in .git, we see that there are hooks. So let's go in the hooks. And in here, we see that there are a bunch of sample files. I can open it briefly, but my editor in my terminal isn't the greatest in terms of formatting, so it's going to look ugly. Pre-commit. And yeah. Alright, so it's important to note that when you're creating a hook, you just need the name to be correct, and for that file associated with that name to be executable. So because these have .samples on them, these won't run, but if you remove the .samples, they should run, in theory. Anyway, moving onward, let's move this back to the original directory. Let's create something. So over here, which is where my editor is, I'm going to create a new directory within source called bin. And then from my understanding of how bin works, because I've been using it recently, but I haven't really looked up why it works this way, is you can create a bin directory and have individual programs there that can run, that have their own main, and you can individually run them, individually build them. They kind of like accessory programs. Accessory programs. Accessory? One of the two. So I'm going to call it bin, and then in bin, I'm going to create a file called Precommit. And I don't care about you. Don't care about you. And let's make you here. So we need to create a program. Let's go back to our example for printing out the arguments. So the reason why I'm doing this is so that, one, I could test the basics of whether or not the commit ran. We can put text in there, then see if it was actually called. But two, I want to be able to see what arguments are passed into my git commit hook and identify them, so that when I actually write that real program, I could use them accordingly. So let's paste that there, and then we need to put this into a function. So function main, and to be nice, we could add a print line to say we're doing something. Print line, you can call it testing precommit hook. Alright. Open the terminal. Let's see if this runs, and then we can see, then we can just build it. Cargo run bin. This is called precommit. Get rid of this green thing. And it looks like it compiled and ran. We see our text here, and we see the first argument of the program. Now, it is important to note that the first argument to any program is the path to the program itself. And that's what we see here. This was built in target debug precommit, which is the name of the file. So when you run things, it builds it for you. It then runs the build program, and then it deletes it. So this is the path to the program that was built and ran. Cool. So let's build it and create a release for it. It is also important to note here that we didn't have to create a release. Release has some default optimizations that might happen at the compile steps. I'm not exactly sure which optimizations occur, but you can tweak those if you like. So let's do that, and now let's move that file into our Git Hooks directory. So we're here. We should be able to find the build that we just made. It should be in target. So let's copy target release called precommit, and we're going to copy it to .git/hooks. And I think that's everything we need. So let's start doing some Git stuff. Git status. And I'm going to add everything in the source directly to stage, and then I'm going to try to commit that. Git add source, and then git commit. So I'll just call this first commit. And then let's look here. We see in our output that the git commit worked. The pre-commit hook worked. It ran. We see the text here, and then we see the path to the directory, or the path to the file. And there are no extra arguments passed in, or else they will be in new lines. All right. So one thing that we did read was that if you want a pre-commit to fail, then you have to give it an exit status that is non-zero. So we can try doing that. In terms of exit statuses, it's in the standard process exit. You could just find it this way. You can search for exit, it pops up. More or less, we have a function called exit and we pass in a code. Seems straightforward enough. So process exit. Okay, cool. So up here, we can do use standard process exit. And then to make this fail, exit code, give it a 1. And that should be fine. So we have to rebuild it. And then we have to copy it over to the Git Hooks repo, directory again, so we can override the previous one. So let's do that over here. Copying it over and overriding it. Cool. Then we do git status. We can see that our source bin precommit was changed. So let's add that. Git add source bin precommit. Now try to commit it. And as you can see, this time it did not go to my editor, as in the hook failed. And the hook still ran. You can tell that the hook still ran because we can see the text here. We have the printed line and then we have the argument, which is the path to the program. Alright, so we just confirmed that if you exit with a code that is non-zero, it fails. For the hell of it, let's put a 0 in here as well, just to test it out. Release. Copy it over. Look at git status real quick. It was modified again, sure. Git add source bin precommit git commit. Ta-da! We are in our editor, so we're writing the commit message. Ta-da! Alright, so now we want to do test, right? We want to be able to run our test in our pre-commit hook. In order to do that, first we need to have tests, because without tests, it's kind of silly. I always forget the documentation or the method of how to write a test, like the DFAT formatting, this thing. The syntax, there we go. So if you go to Rust by example unit testing, you can always just come here and look at it, be like, ah, that's how it starts again. So let's do that. And then let's go to main, and let's add a test. Hashtag test function testing, and we can assert, let's assert that 1 equals 1. Do cargo test to make sure everything works as expected. We see here that we do have the test running and passing. Alright. So now one thing that we need to check is we need to check the cases when the test is passing and when the test is failing associated with the exit code, because ultimately we want to have a 0 exit code for when it passes and a non-zero exit code for when it fails. So let's check that here. So cargo test passed, and the way to check the exit code for the last command ran in Unix, or at least Linux, I believe is echo $? And we see that is 0. And to note, I did not know that off the top of my head. I had to Google that. It took me a while to find. Anyway, let's make the test fail. Cargo test failed. Look at the exit status. 101. Okay, so what this tells us is that in our pre-commit hook, we could directly run the test and then take the exit code from the test, from the running of the test, and then use that as our exit code for the pre-commit hook. And that should be fine. So let's do it. So in order to run the command cargo test in our from a pre-commit hook, we have to understand how to run command line operations or bash scripts from Rust. In order to do that, we can look at, where is it? Here we go. Standard library process command. So the command syntax basically looks like this. You have command, new, you have the command, and then if you want to pass arguments, you can do args and pass multiple arguments, or you can do single args, and it's arg, one argument, arg, another argument. They have things like output and expected because I believe this returns a result. If you scroll down, you can see things like status, and what status does, here we can find it over here. Status executes a command as a child process, waiting for it to finish and collecting its exit status. So more or less, this is what we want, because this is going to give us the exit status of the running of the test. All right, so let's do it. So going back to pre-commit, so we know that it's from process and it's command, and they're both nested from process, both exit and command. So we can just delete exit from there and just do everything from process. As in, instead of having exit there, we write process, then exit. Anyway, let's do this right here. We can say let test equal process command new, and this is going to be cargo, and we have the arg, which is test, and we have status because that's what we want. And you can see that returned a result of exit status. Okay, just out of curiosity, let's figure out what exit status is, and I already have it looked up. Standard library process exit status. This struct is used to represent the exit status of a child process. Child processes are created via the command struct, and their exit status is exposed through the status method or the wait method of the child process. Okay, this seems like what we want. One thing to note is that this is a struct, and if you want access to the actual number of the exit status, then I think you have to use code, which returns the exit code of the process, if any. So yeah, coming down to here, we know that this is the result, so we can match on it. Match test, and it's going to be okay, as in it ran. We call this exit, and we have an exit status. Or it could error out possibly. I'm never really seen it error out. Well, maybe. I guess if it doesn't build, that might be an error. Let's put it error. And we need to deal with these two cases. So we already established that if our tests run, regardless if they pass or fail, we can use the test exit status as our own exit status, and that reflects appropriately. So we can just directly do process exit, use the exit status that they give us, dot code, and then unwrap it so we can get the exit code. In the case of error, we might want to print a message. I believe ePrint goes to standard error. There was an error running the tests. Print out the error. And then we should still exit with something that's non-zero. Give it a 1. And then this stuff about the arguments, we no longer need this. And if we reach the end of the program, we can exit with 0. We can just let it end the way it normally would end, because by default, the exit status is always 0. But we can leave it as well. And we're no longer using this line. Alright, so let's try to build it. Ah, they said that this line is unreachable. That's good to know. Okay, so what they mean here is that in the match test, both options or all options lead to an exit. So this line is never reached, so we can just delete this. That's good to know. Let's build that again. It is built. Let's move it over to Git Hooks directory. And that should be my history. There we go. And let's look at our test. Our test is currently failing. So the pre-commit should fail. Git status, git add source main. Git add source. I think there's multiple things there. Git status. You can see it. Yeah. Git commit. So as you can see in the output, our test ran. And let's move this up a little bit. So here's git commit command, testing pre-commit hook, which is our text. And then here's us running our test. And given that our test failed, the pre-commit failed, which is what we wanted. So now if we change the test to pass, saying that assert 1 equals 1 instead of assert 1 equals 2, this should work. So git status, git add source main, git commit. And voila, we are now at our editor where we can write our commit message. Pre-commit MVP. Alright, so that was the basics of what I wanted to go over today. It should be noted that this is just a pre-commit hook for running your test. However, if you wanted to add things, for example, Clippy, which is a linter for Rust, you can do that as well. And I did note when I was looking into this that Clippy does exit with various exit statuses, so it works almost the same exact way as writing the one we did write for cargo test. One other thing I wanted to note was that I was having issues formatting my code, as in I would forget to format it, and I couldn't put that in the git commit hook, or I couldn't put that in the pre-commit hook because it would always modify the file, and it didn't tell me which file it modified, and it didn't give me error statuses. So, oh, looks like it does have that option. Check. Huh. I see. So I might be able to put this in the pre-commit hook as well. That is good to know. I'll test that out at a later date. Or you can too. If you want to put the format in a hook, it looks like you have to pass in the check flag. Outside of that, if you want to add Rust formatting to your editor explicitly, they do have a section. And this page is the Rust format GitHub page. And if you scroll down to editors, they give you the list of editors they have support for. And they give you instructions for how to add it to your editor. And I'm using PyCharm currently, so IntelliJ is the company, or at least the parent product, seemingly. And the instructions for that are make sure the plugin is installed, and then file settings, language and framework, Rust, format. So all the way here, and then you can make sure it formats automatically on save. With that, we have definitely reached the end of the video. If you like, hit like, subscribe. Outside of that, till next time. Peace.